Hello guys, in this video I'm going to show you how to solve midpoint, linklist midpoint problem. So return the mid node of the linked list. If the list has an even number of elements, return the node at the end of the first half of the list. Do not use counter variable, do not reach it beside the list. Only iterate to the list one time. So if you haven't heard of this problem before or haven't tried before, it's a little bit difficult to come up with a solution. Actually, it uses the technique, a pretty handy technique, which is slow fast pointer. Let's look at the visualizations that I made here. So for the case, the number of nodes are odd. We have 3 nodes. We expect the middle node is B, right? So 1, 2, 3. So B in the middle node. So the idea here is we use 2 pointer. This pointer is a slow pointer and this pointer is a fast pointer. Initially, 2 pointers point the same node, which is the first node. But we try to for each iteration, the slow pointer will move forward 1 step, but the fast pointer will move forward 2 steps. So at the end of the loop, when we cannot move the fast pointer forward, which means the distance, the distance that fast pointer have gone through is double that of slow pointer. So slow pointer at the time being is pointing to the middle node. Let's see an example. So initially it's point to A, right? But now we want to move the fast pointer forward, and in order to move the fast pointer 2 steps forward, it means we can only do that when the next node, the next node, right, is not null, which means I go to B, right, 1 step. I go to C. Yeah, I can do it because C is not null, but I will not want to move forward if C is empty, right? So the slow pointer will go only 1 step, right? And now we couldn't move the fast pointer forward because its next node is null, so we exit the loop. And currently slow pointer is pointing to B, so B is the middle node, exactly what we expected. Let's see another example, which is the number of nodes is even. There are 4 nodes in the example, A, B, C, D, and so let's look at the requirement. If the list has an even number of elements, return a node at the end of the first half. as you can see, the first half is B and the end of the first half is B. So we expect the middle node is B, right? So let's run our algorithm manually. We want to move the fast pointer first, right? Can we is the next node is not empty? Yes, it's not empty, so we can move forward. It's C, right? We move 2 steps. Now it's turn of it's slow pointer's turn. We can move 1 step forward. And now the problem is this fast pointer couldn't move 2 steps forward because the next up next is no, so we don't want to go ahead if it is the case. So we exit the loop here, we stop our loop here, and currently slow pointer is pointing to B, so we return B, which is exactly what we expected. So let's code it out. We need 2 pointer, that's slow and fast. Slow equal to this dot hat list dot hat, and fast also equal to list dot hat. We also want to move forward if the fast we have the fast of next is not null and fast of next is not null. So we move slow 1 step forward. Fast go to fast up next, right? So to exit the loop, we just return slow. Let's run it, just midpoint. Hopefully it will work. Oh, what's wrong here? Odd number, when the list set file element. When the list has file element. Oh, slow, but next, not fast, next. Awesome. Thank you for watching. See you in the next video.